Human eyeballs are growing longer, from front to back, at an alarming rate, resulting in a spike in the prevalence of myopia, or nearsightedness. Among Americans, rates of myopia have increased from 25% of people in 1971 to more than 40% today, according to the National Eye Institute. In the major cities of developed Asian countries, the rate exceeds 80% among students as they graduate from high school. But researchers and eye doctors, many of whom view myopia as a growing epidemic, are largely mystified over the mechanisms behind it. Evidence points to two likely and related culprits during the critical years, infancy to late teens, when eyeballs grow and develop their ultimate shape. Increased time focused on smartphones, tablets, and other up-close tasks in school and during heavy homework loads. Lack of exposure to bright daylight, which is thought to offer a protective effect against myopia. The severity of myopia is also increasing. An extreme form of nearsightedness, called high myopia, nearly doubled from 2.2% of the global population in 2000 to 4% in 2020. It's projected to reach 10% by 2050, according to the World Health Organization. High myopia increases the risk later in life of glaucoma, which damages the optic nerve and is a leading cause of blindness in the elderly, as well as macular degeneration, which cracks and destroys the macula at the center of the retina, ruining straight-ahead vision. We may only know the full impact of myopia as the population ages. Lisa Ostrin, a University of Houston optometrist who studies myopia in children, tells Elemental. Barbara Caffery, president of the American Academy of Optometry, worries that not enough is being done to determine the problem's causes and solutions. We are witnessing an epidemic, one that will bring tragedy, morbidity, depression, Caffery wrote last year in an open letter to colleagues. Surely we will not be known as the myopic ones, the ones that missed the obvious. What is myopia? Myopia develops when the eyeball grows into a pear shape instead of being round, or when the cornea becomes too curved, so that instead of focusing objects on the light-sensitive retina at the back of the eye, distant objects are focused in front of the retina. Close objects may be clear, but things in the distance are blurry. Seemingly small differences have a huge effect. A normal adult eyeball measures about 24 mm (0.94 inches) front to back, explains Langis Michaud, a professor of optometry at the University of Montreal. There's very little variation across the human species. But in the average myopic adult, it grows to 25 mm. Higher myopes, as they are called, can see this measurement exceed 26 mm. A typical toothpick, for comparison, is about 2 mm thick. When he first started in optometry 35 years ago, Michaud would see the occasional nearsighted young person, typically with modest myopia at around age 13 that would stabilize to a moderate level by age 18. This was considered a benign myopic evolution, easily manageable with glasses, contact lenses, and, later on, laser surgery, when that procedure became possible, he says. Now, every week he sees children as young as 7 whose myopia is as bad as the 18-year-olds from 35 years back. If I do nothing, they will become highly myope and will face pathological consequences, Michaud says. The number of cases and the ongoing increase qualifies the phenomenon as an epidemic, Michaud says. He and other experts agree that while myopia can be inherited, genetics can't explain the relatively recent spike in prevalence. A normal adult eyeball measures about 24 mm front to back. There's very little variation across the human species. But in the average myopic adult, it grows to 25 mm. The irony of cause and effect: if diagnosed, myopia can be managed with specialized glasses or, preferably, with specialized contact lenses, which can stall the progression. But kids with myopia may not realize their inability to see the blackboard as unusual, so they often struggle in school, frustrating themselves and their unknowing parents and teachers, according to a report from Education Week. Only 40 U.S. states require vision screening for school-age children, and protocols vary by state. The American Optometric Association says school screenings fail to identify up to 75% of children with vision problems. Education Week's analysis found that 1 in 3 U.S. schoolchildren haven't had any vision screening in the past 2 years. Other research finds only 40% of kids age 5 and younger have had a vision test of any kind. There's a great irony to all this. While myopia can make it hard for a child to read a faraway blackboard, increased time spent in class or doing homework, focusing on books or screens and other up-close tasks, appears to be contributing to myopia, research suggests. But the research has not proven conclusively whether perhaps myopic children are more likely to spend more years in school, or if more years in school and something about the way we educated our children is causing the increasing prevalence of myopia, says Denise Atton of the University of Bristol Eye Hospital in England. In a 2018 study in the British medical journal BMJ, Atton and colleagues found that every single additional year of education is associated with increased nearsightedness. They conversely found little evidence suggesting myopia caused people to remain longer in school. She says her research provides the strongest evidence yet that something about time spent in education is contributing to nearsightedness. It's not a leap for researchers to suggest what's going on. Educators increasingly rely on technologies like tablet computers and less on blackboards and the overhead projectors of days gone by. And today's kids are asked to do more homework than in decades past, again often involving small screens and other close-up work. Close work strains the eyes to converge and focus, Michaud says. Close-up screens generate a visual demand that the visual system of the young kids cannot handle, he says, adding that the effort can trigger eye fatigue, dryness, redness, double vision, and loss of concentration. More education, less daylight, less protection. The extent to which smartphones and other screens contribute to nearsightedness remains an open question. A review of 15 studies on the topic, published in January 2020 in the journal Ophthalmic and Physiological Optics, found mixed results on linking screen time to myopia, concluding only that further study is needed. Research does reveal that time spent outdoors, in bright daylight, slows the progression of myopia, several researchers tell Elemental. A bright day can deliver 10,000 or more lux, a measure of light's brightness at the eye. Typical lighting in a school or office is around 500 lux. But studies find that children and adults are spending far less time outside nowadays. The two apparent contributing causes are related. Very simply, those who spend more time in education may have less exposure to natural light, Atton says. While there may be a link between myopia and the amount of time that children spend doing near work, such as reading, this association is much less consistent across studies than the protective effect of time spent outdoors. Scott Reed, Ph.D., Director of Research in the School of Optometry and Vision Science at the Queensland University in Australia, has studied this connection. Our research suggests that bright, outdoor light exposure is associated with a slower rate of eye growth, and hence a lower risk of myopia development, Reed says. The mechanism isn't yet known for sure, but the prevailing theory is bright outdoor light causes the retina to release dopamine and other chemicals known to slow eye growth, he says. The effect might be twofold. Bright daylight also governs the human wake-sleep cycle by suppressing the release of sleep-inducing melatonin during the day to keep our biological clocks in time. Getting at least 2 hours of exposure to daytime light is thought to protect against possible negative effects on sleep of light from screens in the evening. So, another theory, Reed says, is that bright light helps to better entrain the normal circadian rhythms in the eye, which might also help to promote normal eye growth and reduce myopia risk. The full explanation for what's causing the rise in myopia may turn out to be all of the above. In her University of Houston lab, Ostrin, who researches the effect of light on children's retinas, says the increase in myopia is likely due to a complex interaction of several factors: how long kids spend on screens and other close work, viewing distance, whether they take frequent breaks, and how much exposure to daylight they get. The challenge to finding conclusive answers, she and other researchers say, is the reliance of many studies on self-reported behavior, which is known to be less than accurate, and the lack of objective measurements of reading time, distance, light brightness and other factors. Wearable sensors used in her lab and others are starting to offer better data. With continued use of such devices, we hope to be able to develop evidence-based therapies, such as recommendations for behavioral modifications, that may ultimately lead to a decrease in myopia prevalence and progression in children, Ostrin says. Visual hygiene suggestions: there are practical things anyone can do for themselves or their kids to promote good eye health and possibly reduce the risk of myopia and other vision problems. Children and adults who read a lot or spend significant time in front of screens would be wise to practice the 20-20-20 rule. Every 20 minutes, one should look at an object at least 20 feet away for at least 20 seconds to let the eyes relax the focusing system, says Tamara Oshlin, an optometrist at the University of Alabama at Birmingham School of Optometry. Other advice from the experts: keep screens at arm's length, not inches from your nose. Reduce screen glare by adjusting room lighting and device settings. Zoom in on screens to make type or images larger. Oshlin stresses that scientists aren't certain what's causing the myopia epidemic. This is still a very debatable topic, she says. Everyone's gut seems to know that all of this near-focus screen time cannot be good for us, but we do not yet know what the mechanism is that is causing the rapid change in the development of nearsightedness. With that in mind, perhaps the best advice for kids and teens, or any of us, comes with a trifecta of presumed benefits: cutting into screen time, offering direct protection against myopia, and the added bonus of improving physical and mental well-being. Get outside more.